So now that we're done with the installation, let's go to the slides. Okay. So we have we explained how we can create SQL databases, right? And last session we also talked about how to create tables. So we know you already know that you start with just create table, the name of your table, and then you just list your all the columns that you have in your tables, followed by their data type. There are just a few important things. First is the order of creating tables, right? That is the most important thing. Because in order to create tables in your database, let's say, for example, a student registration, okay? So if you want to create a database for a student registration, with 4 or 5 tables like a student, course, enrollment, and so on, you need to take care of the dependencies and the relationships between these tables. For example, if there is a table with a foreign key that is referencing another table, which table should be created first? The table with the foreign key or the other one? The other one, right? Because otherwise, let's say you are creating enrollment table before creating the course table, okay? So in that case, when you're creating your tables, you reach to the point that you want to define your foreign key, like here, right? So, okay, foreign key, for example, I don't know, a student number references the student table, a student ID column, right? But you have not created the student table yet. So the order in creating tables matter. The order in inserting data into tables matter. The order in deleting tables also matter, okay? And for dropping tables, it would be the other way, right? You first have to drop the ones with foreign keys and then removing the other ones. So you also know how to define the data type of each column. For example, let's say you have the order table, then what could be different attributes for the order table? We have order number, right? Customer ID, and let's say order date. So these are your columns. And then you have to identify what are the data types, because you want to make sure that, for example, a user will not enter, for example, a textual information by mistake instead of order ID, for which you expect numbers, right, or digits. So, for example, you define your order number integer, and this identity, just as I mentioned here, it just creates order number automatically, starting from this number, okay? Can be any other number. Just mention the number here, and then this shows if you want to go, for example, let's say 100, 101, 102, or if you, for example, use 2 here, then it goes 100, 102, 104, and so on, okay? So this is just a distance between the numbers. And you always have to define your primary keys and foreign keys. There are 2 ways to specify a column as your primary key. One is in line with the column. For example, if order number is your primary key, you can identify it here, or you can just put it at the end, like this way, okay? Both are correct. And primary key could be 1 column or multiple columns, right? In case that you have a composite primary key containing different columns, this is how you do that. So you have primary key, for example, order number, product code in the parentheses. It means that it's a composite primary key, right? And so both of them are also foreign key. We have talked about associative entities, how they get the primary keys of the 2 entities they are connected to, right? So if, for example, a student number is primary key in the student table and course ID is primary key in the course table, and we have an associative entity or an intermediary table like a third table like enrollment, then these 2 primary keys will be foreign keys. Why? Because foreign keys are what allowing you to connect tables together, build the relationship between tables, right? So that is how you create the relationships, and then how you translate them into SQL codes, defining the foreign keys at the end, right? This shows you that this table, order line, is connected to which tables? orders and products, yes? Which table is connected to orders? Which tables are connected to orders? Customers, right? Because you are using the foreign key referencing the customer table. Foreign keys are what connecting tables together. So what table connects to orders? Customers. What table connects to product? Nothing, right? Actually, yes, order line, right? Order line connects to products. So this is how you define the relationship. And why did we add the foreign key to the order line and not to product? Why didn't we? So here, when we define order line, we write foreign key product code references product. This is to connect, obviously, the order line table to the product table, right? Because each order line includes a product, right? Now, why did we add it here and not here? Where do we always add the foreign key? Yes, the many side, yeah? And we explained it why. And because you asked me not to review a lot, so I'm trying to control myself not to review. And I assume that you know why, okay? So these are all the important things that you have to know about creating tables, nothing else. So we can just go and practice that after I just move forward a little bit with the slides. And then we have also shown in this slide how we can enter data into SQL. This is also easy. Just use this insert into followed by your table name. For example, insert into products table, followed by column names. You can also skip that. Okay, so it's okay if you just write insert into products and then followed by all the values as long as order is correct. Okay, so you have to, for example, if the order of the column is product code, product description, and price, and then you skip this part, you have to make sure that you are entering product code value, followed by product description, followed by the price. Okay, this is important. And in order to insert multiple rows at once into a table, you can still use the same. So you are still using insert into, for example, a table products, okay? And then you can, as I said, have the column names or not, right? And then you enter the values. So these are values of the first row, values of the second row, values of the third row, and so on, okay? So you can just list each row in one set of, like, one parenthesis, followed by the next row and the next row, and so on. And so these are just some information about data entry with SQL. So for example, if you are using a data type like car or varchar, which are used for what type? Characters, right? If you have something that is either only like text or mix of numbers and like textual like characters, then you can use, based on whether it's a fixed length or not, you can use car and varchar, and you always have to use the quotation like this. And if you're using a number, like integer numeric data types, you can just directly write them. So if I go back here, as you see, I put these two in the code while the number should not be. Otherwise, you'll get an error and then you'll fix it. No big problem. And then another point about the date format and the fact that the insert is subject to integrity controls. What does that mean? Again, the order matters, right? The same thing that we discussed about creating tables. So you should enter data into products and customer first, then orders, and then order line. The same thing that we did with the creating tables, okay? Just a few commands to show you how to alter tables. So this session is, as you've seen, is SQL DDL, or data definition language. If you remember, we said for data definition language, we talk about anything related to the structure of your database, right? And what do I mean by that? Like when you're creating a table, when you're altering a table, but what I mean by altering is modifying is a structure, like adding a column, right? Dropping a column, changing a data type of a column, but not updating a value of a column, okay? So if you want to update a value in a column, that's you will not use alter. For that, you're using update view, which we'll discuss in DML or data manipulation language. Data manipulation language is about anything that you do with respect to the data into your tables, nothing to do with the structure, okay? And that is why deleting a table is very different. Deleting is different from dropping. When you drop a table, drop is a DDL command. It drops a table completely, not only the values in it, but also the structure, indexes, everything. Anything, like you just wanted to diminish everything, okay? So you don't want to have anything about that table. But if you're using delete statement, then that's different. You're just deleting the values in a table, but the structure is there. Now, so this is how you use alter table. For example, if we want to like add a column, you just write alter table followed by a table name, adding that column, of course, followed by the data type. And then if you want to change the type of a column, the data type, for example, let's say a column is, I don't know, numeric, and you want to change it to integer. Or if it is car, you want to change it to varchar, and so on. So this is how you change that, okay? So you write alter column, and then you specify the new data type. This is how you drop a column from a table. Dropping a column from a table means that you are actually altering that table, right? You're changing the structure of the table. So you use the alter table command followed by a dropping column. And also adding constraints, which is important. So we have several like constraints. We have, for example, primary keys, foreign keys, check, and so on, okay? So I provided like just a couple of examples. For example, let's say you have a column, you have a database, or you have a table for which you want to add some constraint on the age of people, right? So, or for example, you have in the context of a student registration, for example, for the grade, what could be the constraint? Let's say if your grade is a letter grade, A, B, C, D, E. So you want it to be in this range, right? You want to add a constraint that if someone entered a numeric number or anything other than what you specified, it then violates and should get an error. Same thing, like if you have like numeric grades, so you have, let's say, from 0 to 100%, okay? So you want to make sure that grade is greater than 0 and less than 100. So that is how you identify this type of constraint using check, okay? So for example, here we have a person table. So we alter table person, add constraint, and this is just your constraint name. So you can put whatever name that you like, followed by check, and then the constraint that you have here, the constraint is that age should be greater than or equal to 18. And age is the column that you are putting the constraint in. And finally, this is another way of defining your foreign key. So if you remember, when you were creating tables, I mentioned that at the end of creating tables, you can specify, for example, primary key, column 1, or foreign key, for example, this column referencing this table, this column, right? Another way to specify that is writing add constraint, name of the constraint. For example, FK means foreign key category, and this is your foreign key. And so it should follow by, sorry, I don't know why it doesn't show the full page, but it's not ended here, obviously, in your slides. You have, after foreign key, you have references, the table that you're referencing, and the column in that table that you're referencing, okay? So let's practice a little bit, and this is how you drop tables. You just write drop table, and then the table name. And the important thing here, again, is integrity control, okay? So again, the order of dropping table matters, and it's the opposite way of order of inserting and creating tables. So for example, to drop a table, you need to drop tables that have foreign key before dropping tables that providing those foreign keys. For example, dropping the order line table before the orders. Why is that? For example, in the student registration example, back to that example, we have, let's say we have 3 tables, a student, course, enrollment. So which tables should I create last? Enrollment, right? So we should first create a student and course and then enrollment, because enrollment has foreign key that is referencing them. When you're inserting data into tables, the same, right? Now, if you're going to drop tables, which table should be first? A student, course, right? And then enrollment, right? Right? No. If you're dropping a table, you have a student, course, and enrollment. We have to first drop enrollment. And why? Because we have, let's say, student here. This is a student table. And we have, let's say, enrollment. We have course, right? And then here, in the enrollment, we have 2 foreign keys, right? One is a student number, or a student ID. This is one foreign key. And we also have course ID as foreign key. Now, what is the problem if you first delete the student table? Let's say I drop a student table before dropping the enrollment table, okay? Then you have a table including a column referencing a table that doesn't exist, okay? So you have to drop enrollment first so that you get rid of like these links. These are a link between these entities, right? So you have to remove these first and then dropping the student and course. So here are the explanations for connecting to SQL Server using Azure Data Studio. So for those of you who are using Azure Data Studio, this is the screenshot. This is what you have to enter. You basically, the only thing that you have to enter, don't play with the others, okay? Just the ones that have like this red star. So server name, authentication type, you should make sure that this is SQL login. And then username and password, and then that's it. And then, sorry, just one more thing. You have to make sure that you trust server certificates. So this by default is false, but you have to make sure that this is true, okay? So that you trust the service, the server. And then click connect. So this is for Azure Data Studio. If you're using SSMS, okay, Microsoft SQL Server Management Studio, then this is, okay, so sorry, this is for how to create a table. I maybe skip the, you will have the same interface. Because if you have used, for example, VS Code, you see that we have seen the same thing, right? So they are all the same. Whatever tool that you use to connect to your database, whether it's Visual Studio Code, whether it's Azure Data Studio or SSMS or anything, it always asks for your server name, your database, and password, right? Because it want to know where to connect to. And so these are the information that you need, and you know where to find them. And this is these are just some screenshots of how to creating tables. If you're using SSMS, I provided this screenshot just to give you more options for students who have Windows or who prefer to use SSMS. And because in this class we focus on Azure, just wanted to provide more options. And okay, let's go back from here. So whatever you need when you want to connect to your server is here. So you just go to your server or your database, right? So for example, here you can see your server name. So you can just copy your server name from here. Same thing is here. So you could also use, for example, this one. Doesn't matter. This is still your server. Sorry, this one. Okay? You still have your server name here. And the other thing is if you click here and go to show networking setting, you make sure you select selected networks. This is in case, because it happens. It sometimes happens when you change your location, change your laptop, or even none, but sometimes happens. You, for example, provide your server name and everything. You click connect, but then you get some errors that it doesn't recognize your IP address, any error regarding your IP address. This is how you fix that, okay? So if you want to fix that, you just go here in the network setting. You're adding your IP address the same way that I did earlier this morning, and make sure that this is checked, okay? These are everything you need to know. Now, going here, I'm going to, because I've already created tables here, so everyone should see if you're connected to your SQL server, you should see it as like green, this green, small green circle here. So if this is green, means that you're connected, okay? If it is red, means you're not. Now, you can just extend it to see your databases. So you should be able to see these. The only difference is that you probably don't have the tables that I created before. And I'm going to drop that tables now. I'm going to drop all those tables so that we create them again together. So, do you need a break? Or do you want to just continue? How many says break? How many in favor of break? Like 10 minutes break. Oh, we have lots of motivated students. How many of you are in favor of just moving forward? And I don't promise you I finish earlier. Okay, break again. Okay, so we'll continue, I think. And for those of you, if you need break, it's fine. You can just use 5 minutes. And okay, so these are the tables that I've already created. I'm sorry? Yeah, I explained it before. You
did try.
No, this is SQL tools. I said MS SQL. Should be, sorry, this one.
This one?
No, this one.
Well.
Yeah, here, this one. Just create new.
It's not working with it.
Then enter your, it should ask for your server name first.
I'm not sure.
Okay, here, SQL Server, okay? You just go to add a connection, enter your server name, and then username and password here.
Okay.
And then click connect, should be okay. Okay. So let's drop the tables that I created first, so we create them together again. One thing about whether to use like lowercase, uppercase, doesn't matter with SQL, okay? Just make sure you stick to one thing. I'm using uppercase all the time. Drop table. Okay, so as you see, I have course, enrollment, instructor, student. Which table should I drop first? Which table should I drop first? We just talked about it. Student. And we may get an error if it has a foreign key, okay? So you see, for example, we have a student table here. You can see other information like the foreign key. So it has a foreign key, right? So I cannot drop it first. And if I do, I will get an error. So let's do and see what error we get. So this is not the error that I expected, honestly. I expected the error being related to the foreign key. So let's see what's the problem here. So let me do it like just a Okay, so I think I'm still not in the correct place. Just give me a second to. Okay. And then I will try with the DBO too. Okay, so it works. Okay, and let's drop the student table. Drop table student. So we should get the error, right? So this is the error that I was talking about. So if you're dropping a table that has a foreign key before a table that is its parent, this is the error that you'll get. Couldn't drop a student because it's referenced by a foreign key constraint. This is the problem that I was explaining. If you're trying to remove the student before the enrollment, because there is a foreign key here referencing this table, it cannot remove this, because if it remove it, you're ending up with a table referencing something that it doesn't exist. So which table should I drop first? Obviously enrollment, right? Okay, so now this is dropped. So if you refresh this, you shouldn't have the enrollment table, and we don't have it, right? Now, after that, which table can I drop? I think this instructor table. I think so. Let's see if we have a foreign key here or not. We don't have, so we should be able to drop table instructor, followed by table. We already removed the enrollment, and then removing the instructor. So we should be able to drop a student after instructor, right? So because in a student, we have a foreign key referencing instructor. Sorry, so we have to drop this one first. Okay. Now it takes some time until I go back to the Windows, using Windows. Oh my God, I hate Windows. So should be fine, and then instructor should be okay now. Yeah. Okay, so this is also referenced by something. So you can always check, right? So I think it should be course, right? So let's drop the course too. Because the course table, as you see here, is referencing the instructor table, right? The course table also has a foreign key instructor ID, which is referencing the instructor table, so I cannot drop instructor before dropping the course, right? We have to first get rid of that. So if I write this way, it should be okay now. Drop table instructor, okay? Now, if I refresh this, we got rid of all the tables for the student enrollment, right? We don't have a student or course instructor, so we dropped all of them. Now let's create the tables together. And just for your information, I have included some files here. So if you go to practice, so in module 5 practice, and I highly recommend you not copy paste this, just use it in case if you face some errors or if you were running time and wanted to catch up with the class. I provided the statements to create all the tables that we need to practice in class, okay? So these are to create, for example, instructor first and then a student. This is another way just to define a foreign key, but these are the same tables. And so as you see, I first create the table a student, and then course, then enrollment, and so on, right? So, and you can also find the statements how to insert data into your tables. you have to also make sure when you want to enter data into your database, it's very important because there are some data types that you've defined, right? So for example, if you have entered char 4, right, for a student number, what do we expect? Characters or numbers up to 4, like not more. So if you're entering like something like 1, 2, 3, 4, 5 as a student number, you'll get an error, okay? So be mindful of the data types when you're entering data. So let's go back here. Please do not copy paste this. Try to write it as I'm doing, okay? Okay, so I'm going to create the tables that we need for the very simple example that we use during this class, a student registration, with 4 tables, okay? We can even focus on 3 tables for now to just keep it simple. A student course enrollment, because we don't have much time. So I'm going to create, so if we have a student and course, and let's also add instructor, doesn't matter. Instructor and enrollment, which table should I start with? Yes, why? Yeah. So now you see why when I was teaching the data modeling part, I emphasized the importance of data modeling. Do you realize it now how important it is? Much important than the SQL part. Because now you will waste a lot of time if you don't know the logic and design in your mind. You're starting with, for example, creating table student, and then after creating the tables, writing the statement, you will get the error. Because in the student table, you have like these foreign keys links, right? So it doesn't let you to create at all. So the table will not be created. So you will, yeah, so we can check. For example, if I'm just going to create, let's say, table instructor first. What columns do we have? I want to be consistent with the example I used. So we have instructor ID, I think. Instructor ID. And for instructor ID, the data type depends on your database, right? If the employee ID or instructor ID is only like numbers, you can use integer, or you can use, for example, if it is something like, I don't know, a combination of characters and then like A, B, 1, 2, 3, then you can use, for example, car or varchar. So here I'm using just integer. And so this is my data type. Is this my primary key? Yes. You have the option to define your primary key here, right? Or add it at the end. So both are fine. Now, one more thing is that you also want to define where you allow null or not. So if you're not going, by default, it allows null. If you have a column that you do not want to allow null values in that, you have to specify. Now, should I do it for instructor ID? Doesn't matter. You can do or not because it's primary key. And primary key by default, it just enforces not null. Okay, so only for primary key, if you don't specify, it doesn't matter. But let's say you have, for example, instructor, I don't know, first name, and you want to make sure that the instructor name is not null. If that is something that you want, then you have to also specify, for example, instructor first name could be varchar up to, I don't know, maybe 40 characters and not null. Okay? Adding not null here, it means that you cannot, when you're, it means that your table doesn't allow null values in this column. Okay? So for me, I'm okay with that. I'm okay that if it is not null. And then we have, let's say, instructor last name could be again car 50. What other columns do we have? I'm just adding everything because we may not have time. I use varchar here too. So the decision to use char or varchar depends on whether it's a fixed or not, right? And then we already have defined primary key. Do we have a foreign key here? If we have, you define. If not, we just leave it as is. So we always have comma except for the last one, and then semicolon here. So this is just to create the table instructor with these columns. Let's see if we have. So now we have created this first table here. So we have, if you refresh it here, you see that you have instructor table added, right? And now this is just a DDL command that is about the structure of a table. So if I click on this, or in VS Code it doesn't maybe show me that, I'm going to select from instructor. This is just to get everything. We will learn it in learn more about the select statement in DML or data manipulation language. For now, I just want to show you that this table is empty now, as you see, right? We only have the structure of the table, including columns, instructor ID, instructor first name, last name, rank, and that's it. This is what we have. Even if you don't want to use that, you can select top 1000 from here. If you just click right on the name of the table, you can get the a statement that was used to create the table here. If you want to see, for example, what was the foreign keys and so on, like any information. As you see, I'm just want to show you. See, you can get all information about the table creation and what else. You can also edit table and so on. Okay. So these are just all the options that you have. Now we have created the instructor table. Now let's say I have this design with, I have the student. Okay. I have a student here. Okay. I have instructor. I have course, and I have enrollment. And these are my columns, right? And okay, these are connected. For instructor, I have instructor ID, first name, last name, and ranking, where instructor ID is my primary key. And a student and course also have relationship, right? So, sorry, with enrollment, because they already have many-to-many relationship, right? And so this was a connection between student and enrollment, right? So here we have a student number or a student ID, which is your primary key. Again, a student first name, a student last name. We also have a relationship here, right? Because each student can have an advisor. And this is where, if you say each student can have, for example, one advisor and one instructor or one professor can advise many students. So this is a one-to-many relationship, right? And that is why the foreign key is added to the many side, right? So this is your many side of the relationship. That is why when you create these tables, now that I'm going to create the student table, I'm going to add not only these columns, but also advisor ID as the foreign key, okay? keep in mind that also here, after I created, for example, a student and course, once I created both of them, then I can create the enrollment because we have course ID and student ID as a foreign key referencing these two tables. And the reason that is these are added like the foreign keys to the enrollment table is because, again, this is a one-to-many relationship. This is also a one-to-many relationship, right? And the foreign keys are added to the many side. So keep in mind just this design when we are creating tables. I'm not sure if I also included any relationship between instructor and course in my design. That could also be possible, right? Each instructor can teach, for example, multiple courses. Each course can be taught by one professor. And if that's the case, then you have also a relationship between, so this is not the cleanest way to write this, but sorry. Like each instructor can teach multiple courses. Each courses can be taught by one instructor. So here we have maybe course ID, I don't know, description or any information, which is this is your primary key. And then we may also have the course description or some other columns. And then again, because this is a one-to-many relationship, the foreign key is added to the course. So when you are creating the course table, you will have to make sure that you add instructor ID as the foreign key here, okay? So I've created the instructor table. Now, let's create, so this is the last table. I'm going to type this statement to create the table, and then I'm copy and paste, okay? Create table, you do it with me. So we've created an instructor because it didn't have any foreign key. Which table can I create next? Can I create course? Yes, now we can, because course has a foreign key, which is instructor ID. Because we already created the instructor table, and we have instructor ID here, so the link is okay, so we can create course. Can I create a student before course? Yes. This is also on the one side, doesn't have any foreign key, right? So doesn't matter. So in this case, we can either create student or course after the instructor. And the reason is because first, student doesn't have any foreign key. Course has a foreign key, but we've already created that, okay? So should be able to create both. So let's create, for example, a student table. Now, for the student table, what are the columns that we need? For example, we have a student ID, first name, last name. Does it matter if we write lowercase? No. Major, right? So what do you suggest for a student ID? The data type could be integer, right? And this is also our primary key, but this time I'm going to define the primary key, not here. Just want to like show both cases. Like you can also write primary key here. Doesn't matter, right? Either here or here. Primary key is a student ID. Now we have a student ID, integer. We have first name, var, maybe 40, last name again, car 50. Again, as I mentioned before, this could be also our car. The reason I'm using varchar is because they might have different length, right? So if I'm going to define it as a fixed number like car 10, what if there is a major that is like 12 with the length of 12 characters? So just to make sure. You can still, if you are 100% sure that like there is no and will not be like a first name, last name that exceed, let's say, a specific number of characters, you can still use car with like specifying the maximum length of the characters. If you don't allow null, you can just specify not null there. And I can write not null here. But even if I don't, doesn't matter because student ID is primary key. And defining a column as primary key enforce not null. Do we have foreign key in the student table? No, we don't have. Are we done with creating table student? Yes, we are done. Can I go and create the next table here? Yes, it just run them in order. So either you can create it and then go to the next one, or you can just do it in order here. Create table course. Now, what did we define for the course? So let's say, for example, course ID which is now course ID is like, for example, let's say when you say ECS 3421. If in your database that is something fixed, then you can use, for example, car, right? So you can use car, for example, 10. I'm going to stick to this course name. Var car. What do you use for course name? Var car, right? 50 could be enough. This is the maximum length of that you would expect that column receive, right? So we have room var car 20, and so we are creating the course table now. And for this one, I'm going to define primary key here so that you see both versions, okay? Now, do we have a foreign key? So we define the primary key, we define the main columns, and we define, so do we have in the course, do we have a foreign key? What does foreign key mean? A connection to another table. Does the course table have a connection? Yes. Is it on the one side or the many side in that connection? Here is on the many side in relation with the instructor, which means the instructor ID will be a foreign key here, right? So we have to add a foreign key. Foreign key. And what is your foreign key? Instructor ID, right? Now a question. Can I write, instead of advisor ID, can I write, for example, instead of instructor ID, I use advisor ID? Another name. Is it possible that I use advisor ID? Is this correct? Why? Your response is very logical and it makes sense. Yeah, we really expect that it should gives us an error, but it doesn't. Why? Because we have like a references here, and this is where it can understand which column this is referencing. So when we define a foreign key, we say, okay, the advisor ID here, let's say this is advisor ID, which is your foreign key. This is the same as instructor ID. So these are same columns with the same content, just different names in two different tables, okay? So I intentionally use the different name so that you will see that you will not get an error. So references, which table? Instructor table. Which column in the instructor table? Instructor ID, right? Now I have to make sure that I use the exact same column name that I used before. Okay. So let's run this. Doesn't work? Yes. Okay, so this one first. Okay. Control V. Errors that I don't know. Oh, we didn't create that. Sorry. Yeah. So we didn't actually create that yet. So advisor ID. And so one important thing here is the data type. Okay, the name can be different. So you can use advisor ID in the instructor table, instructor ID in the instructor table, and then in the course table, use it as another name like advisor ID. That doesn't matter, but the data type should be consistent. So whatever data type that you defined for instructor ID in the instructor table should be exactly the same here. So what data type did we define for instructor ID? Integer, right? So we have to define integer again here. So now we've created, I think, all the tables except the enrollment, right? So we have, if you refresh here, we have the course, instructor, student. So we only have to create the enrollment table. So enrollment. Now, what columns do exist in enrollment table? We have a student ID, right? And I'm going to use a student number this time. Again, it's a different name, right? Even though it's the same column, right? So we have a student number. So the data type should be the same as a student ID in the student table. What was the type? Was, I think, integer, right? And so this is a foreign key, right? Should I allow null or not? Does foreign keys allow null or not? I should write not null here. Think about it. I just leave it as is, but think if it is needed or not. A student number and then course code or course ID, and then can have a different name from the course ID in the course table, but it still should have the same data type. What was the data type for the course code? I think I used car, right? Because we said it's like ECS 3421. So I use car 10. I'm using the exact same data type here. So I'm again using car 10. If not, we'll get an error, okay? So you can try with different data types and you'll see that you'll get an error that they are not consistent. So back to my question. Can a student number and course code in the enrollment table be null? Can foreign key accept null values? So this means in the enrollment table, I cannot have, for example, a student which is not enrolled in any courses yet. Foreign keys can be null, right? And I'm talking in general. I know sometimes, depending on your design and the constraint that you have in your mind, you may define it as not null. The same thing that we have like for first name, last name. Maybe I do not want to allow not null for the student first name. But is it mandatory? No, it's not. Now, the problem here is that these are foreign keys and can be null. For example, consider the relationship between a student and advisor, right? Although each student can have, like, for example, an advisor, but we can also have students without any advisor. So if you're talking about a foreign key is not like primary key. Primary key cannot accept null, but foreign keys can accept null, and that's fine. So here, we don't actually need like not null. We can think of like students that have not enrolled in courses yet. Maybe we are like in a specific semester that they haven't enrolled. So we may have null here. We can allow it. And or maybe it's a new course, no one's entered in it yet, enrolled in it. But if you want to use that, it's fine. So primary key. What is my primary key here? A student number and course code, right? Both of them. Do we have foreign keys here? We have two foreign keys, right? So we have foreign key, a student number. What is referencing to? Number. A student. And what is the name of the column in the student table? You can check. I think it was a student name. A student ID. Sorry, student ID. A student ID. And What else? Do we have more foreign keys? Yep. We have also a foreign key. This keyboard is like really getting me crazy here. Course code. And references the course table. And let's see what was the name here. Tables, course, columns, course ID. So here should be course ID. Are we done? Yeah. And so we have created this. You can always see if you have any problems here in your query result, which we don't have. So if you just refresh your tables, you can see that we have created course, instructor, enrollment, and a student. So we have all the tables that we want, but all the tables are empty right now. So now insert some data into our tables. How do we do that? You just write insert into, then your table name. Can I just enter data into a student first? No, because a student have relationship with this instructor, right? One-to-many relationship, and it's in the many side, which means that it has advisor ID as a foreign key here, which means we have to create instructor first, and we also have to enter data into instructor first, right? Because then we have some null values there, which are referencing some values there that are referencing null values in the other table, right? So insert into instructor first. Now you can just include all the columns in order and then write values, all the values in order, okay? So what were my column names for the instructor? I have used, that is why I had to copy paste those, because now I don't know what I've used there. Instructor ID first and last name, okay. Instructor ID. Instructor first name. Instructor first name. I honestly don't know what I do. First name and instructor last name. And also rank. We also have rank. Okay, so how about the values? So let's save some time and enter values from here, okay? So I'm going to enter these values. So first of all, we started with a table that does not have any foreign key, so it's fine, right? So it's correct that we started with inserting data into instructor. The format, like the syntax, I think is fine. The name of the column is fine. And then we entered all the rows at once, and that should be fine. Make sure if you're using integer, you just write it as is, okay? So now, if I'm going to select star from instructor, now my table should not be empty anymore, right? So you see now we have a table with some data here. So we inserted data into instructor. What is next? Can I insert data into course or a student? Think about it. Can I insert data into student? Yes, a student is connected to instructor and enrollment. From the relationship from student and enrollment perspective, from this relationship, which one should be created or have data entry first between a student and enrollment? A student, right? So far, good. And then between a student and instructor, we had to create instructor first, insert data into it first, and then a student. So I can actually enter data into student now. How about the course table? Can I enter data into the course table? Yes. Again, for the same reason. Is this clear? So you just do the same. I'm just going to copy and paste to save time, okay? So I'm going to enter data into student. I just think that I have to change the column names. I didn't use the same names. Okay. The student ID, first name, last name, major. Okay. Oh, we didn't add advisor ID. I'm going to add that later. Okay, before this. Student and advisor. Or maybe we can skip the relationship between student and okay, you have two options. If you want to have a relationship between a student and advisor in your database, I forgot to add a column advisor ID in the student table, but we can always use alter statements. So you can use alter table student, add, for example, a column advisor ID, right? And with a data type that you want to have. For example, the data type of the instructor ID, I think, was integer, so we use the same data type, okay? One more thing that you have to keep in mind is that advisor ID should be added as a foreign key to the table a student, right? Because it's the primary key in the other table. Back to the slides. If you remember here, I explained about adding constraints, right? Like check, like foreign keys, and so on. So one more thing that you should do is to alter table a student, right? And then adding a constraint, foreign key, like you can write any constraint name that you want, and then write the foreign key advisor ID, okay? So that is another thing that we have to do, and then references, instructor ID, and so on. Just to save time, I am going to use this without advisor ID for now, but hopefully you got the idea. And then just want to make sure that we also don't have it here. Okay, and that's it. Okay, so what other tables we left? The data into the course. And please make sure if you already insert the data, for example, into the instructor, which I did, make sure to delete it. If you just put it like, because you've already inserted data into that, you will get an error. So just delete it and then insert into the next one, or just write all of them together and then run once. I think I used different names. So here I used course ID. Course ID. Okay, so also instructor ID, I think I used advisor ID here. So I'm going to change that to advisor ID. But if you just use my file, that is fine. You don't need to change anything. And so just run this and then we're fine. So we have data also into the course. Just what is left is the enrollment table. Oh, we didn't create the grade. Okay, that's fine. We add it later. That's fine. You can stick to the statements that I provided in the file because it's more complete. But in the class, I just use this version for now. Now, if you also start from course and then content and then next So you should be able to see all the tables here, right? So this is your course table, this is your student table, and this is your enrollment table. Now, okay, so we've learned how to create tables, enter data into tables. And next session, I'm going to explain about a little bit about indexes, views, and so on. But please stay for a few minutes. I want to talk about next session, your midterm exam. Also briefly about what you have provided me